Everybody, today what we're going to be doing is looking at 9.1 recursive and explicit for quadratics. So this is a modified lesson from 9.1, so make sure you have the proper handout. It's not the one from the main packet, it's a side thing that I made that contains some of the problems. So really quickly, let's just go over what a quadratic is. We've kind of looked at this before, but what it's going to do, it's going to make a little U-shaped either going up or a U-shaped going down. We explored this last year, but we're going to focus it more in detail today. There's important things about this, that it has symmetry, it has a vertex, and one of the values, our x value, is going to be squared in order to get this type of shape, and that's going to be our highest exponent. So we're going to look at two things. We're going to look at recursive and we're going to look at explicit. Let's go ahead and start with looking at recursive. So recursive, as remember, is how do I get to the previous, how do I get to the next value? So we looked at this in two ways. Previously with linear, so if I had like a linear equation like 5, 7, 9, 11, you can see what I'm doing is I'm adding 2 each and every time. Okay. We also looked at it with exponential and had like a growth factor. So if it was like 3 to the power of x, it would look like something like 1, 3, 9, so on and so forth, 27. It was increased by a multiple of 3 each time. So now what we're going to do is first we are going to look at this pattern, and then I'm going to go over how to come up with an recursive for quadratics. So the first thing is we're just going to be looking at this shape. It makes like an eye, and we can see we have a total of, what do we got here? We have a total of 7 blocks here. So it's like basically I'm looking at these little sections right here. And then here now I have, bring up my highlighter. Here it looks like I have these 4 blocks. And there's 7 of those. Okay, so that would be a total, that's just 4 times 7, so that would give me a total of 28. And then if I continue this process, we're going to go ahead now and look at this one. Same idea, now I have 9 blocks and there's 7 sections, so here I'm going to go ahead and kind of scribble this in. Here's one section, second, so I have 7 sections of 9 blocks, and 7 times 9 is just 63. Okay, so on our notes it says I want us to make a table, and we want to go up to terms 4 and 5. So if I did this, I would have my figure 1, figure 2, figure 3, figure 4, figure 5, and we already did the first 3, where this was 7, the second one was 28, the next one was 63. Now picture this, guys, if I have now a little 4x4 block, I would have 16 total blocks right here, and picture doing that except I have 7 of them, and 7 times 16 is 112, and same thing now if I did this with, if I had 7 5x5 blocks, that would give me then a total of 175. Alright, now the next thing what we want to do is we're going to recall this thing that we looked at last year. And if you guys remember what first difference is last year, I'm going to just go over a quick linear example right here. It says if I have consecutive x values, like 1, 2, 3, 4, I take the corresponding y values, so we can do the same thing here, like 9, 12, 15, 18. So if I have consecutive x values, I'm just going to subtract the corresponding y values. And if they're all the same on my first difference, it's linear. Okay, now what we're going to do is introduce a second difference. And the second difference is very similar. I'm just going to take my first difference values and subtract those. If those are all the same, I will have a quadratic equation, something that'll make a U-shaped. So let's go ahead and do these. When I make these tables, I try to be as organized as possible. So I'm going to put an x right here because there's going to be no value for that first difference. But then to increase from 7 to 28, I'm going to increase by 21. Then I'm going to increase from 28 to 63, which is 35. And then 63 to 112. And you guys could just subtract these if you want, but you'll get these values. You get 49. And then if I found the difference between 175 and 112, that's a difference of 63. So when I look at this, I know it's not a linear value because my first difference are not the same. So then what I'm going to do is I'm going to go ahead now and look at my second difference. So I'm going to put an X on my first 2 spots because I can't find the differences there. But the difference from 21 to 35 is 14. 35 to 49 is 14, and 49 to 63 is also 14. As you can tell, all of these values are exactly the same. So that's how you can tell it is a quadratic equation. Okay? Now what it's going to do, it's going to ask me to come up with a recursive function for this sequence. So if you remember, what we need to do is always just find the previous, how we do these was take the previous value and do something to it. So for instance, this is what this looks like if we forgot. To get to the current value, what we need to do is take the previous one and we need to do something to it. So for linears, we just added a number. For exponential, we had a multiplication. And for quadratics, what we are going to do is add a linear equation. Raise that up, equation. And some of you might be thinking, well, how am I going to get a linear equation here? So remember, the linear equation, we're just looking at the mx plus b. And what the slope is, it's going to be my second difference. Okay, so that's easy enough. And then my b value is you're just going to solve for it using an x value and a value from your first difference. You're basically just going to plug that in and solve. All right, so let's go ahead and do this. So we're going to set this up, and I'm going to write my final answer down in red in here. So I already know to get to my current value, what I need to do is take my previous value, and I need to add 14x, one more time because that's my slope, and now I just need to solve for my b value. So in order to do that, in pink, what I'm going to do is just choose one of my values from here. Let's switch a different color. One of my values here and corresponding values from here. So it doesn't matter, you can choose 221, 335, it doesn't matter. I always choose the ones I think are going to be plugged in easiest. So I'm going to plug in 2,21 in here. So I'm going to get this value of 21 is equal to 14 times 2 plus b. And I'm getting that for this part right here. I'm solving for the b value. I'm solving for this plus b right here. So I'm just plugging it in. So this will give me 21 equals 28 plus b. And when I subtract 28 on both sides, I'm going to get negative 7 is equal to b. So now I have that. So the recursive formula for this then is just the function of x is equal to the previous term, f of x minus 1, plus 14x minus 7. Remember, guys, since it's a quadratic, you're always going to be adding, or technically subtracting, this type of linear equation to it. Okay? So that's the only thing we're trying to figure out there. So let's go ahead now and look at a second one. So part 2, I have this little staircase. So figure 1, I have this one block. Figure 2, I basically have the stage before it. I'm adding the current stage, so on and so forth. So it looks like I have 1 block, I have 3 blocks, I have 6 blocks, I have 10 blocks. So right here now it says go ahead now, and I want to go ahead and make a table for this. So we'll go up to 5 again. So like 1, 2, 3, 4, 5. And on stage 1 I had 1 block, stage 2 I had 3, on figure 3 I had 6, on figure 4 I had 10. If you notice here, I added 2, then I added 3, I added 4, and if I added 5, this would give me 15. So let's go ahead now and see if it's linear. Remember, guys, you can't just take any y values and find the first and second difference. You need to find it with consecutive x values. So let's go ahead then and do that. If I did the first difference from 1 to 3, it's 2, 2 to 3, 3 to 6, it is 3, 6 to 10 is 4, and 10 to 15 is 5. As you guys can see, this is not linear because it doesn't have a constant first difference. Now let's see if it's a parabola, if it's a quadratic, by finding the second difference. The difference from 2 to 3 is 1, 3 to 4 is 1, and 4 to 5 is 1. So right here, you guys can tell that this is a parabola. It's a quadratic equation. So to find the recursive one, to find the current term, what we're going to do is take the previous term and add some type of linear equation. As a reminder, the second difference value, these are going to be in recursive form, this is going to be the slope on that thing that we're adding, so that's going to go right here. And we need to find the b value. And we do that by, once again, we are just going to use these as my y's and these as my x. Doesn't matter which point we use. And so we can just use like the 3. So 3 comma 3 to plug this in. So if I have this equation, 3 equals mx plus b. So I have a slope of 1 times 3 plus b. This gives me 3 equals 3 plus b. And when I subtract 3 on both sides, I get 0 equals b. Perfect. So then when I go ahead now and look at this, my final answer, which I'll write right here, I just noticed I just did this all here. But you guys get the point. So right, all of this work should be under number 2. So you guys get the point. So the function of x is equal to the previous term plus the linear equation. So this would just be 1x. And it kind of makes sense here because if you look at this figure, guys, if you're at figure 2, I'm on stage 2. This is basically the x value. And I'm going to add that to everything previous. Stage 3, 3 blocks, and then I'm going to add everything previous. And stage 4, 4 blocks, then add everything previous. The pattern continues. So that's just another way to view this. Okay, so now it doesn't always have to be on, what's it called? It doesn't always have to be on shapes. We can always just look at a sequence. Now when I look at this sequence, guys, this is going to be my first term, second term, third, fourth, fifth, so on and so forth. So if I have 1, 2, 3, 4, 5, and I plug in my values of -2, 1, 6, 13, and 22, we can go ahead and find the first difference. When I'm just going up by -2 to 1 is 3, 1 to 6 is 5, and you can see I go up by 7, and then I go up by 9. And when I find the constant second difference, from 3 to 5 is 2, 5 to 7 is 2, 7 to 9 is 2. Since it has a constant first difference, a constant second difference, I know it's a parabola. So what we're going to do is just do the f of x is equal to f of x minus 1 plus a linear equation. So let's go ahead and figure that out. First off, I know my slope is going to be 2, because that's what my constant second difference is. So I'm going to have the f of x is equal to f of x minus 1 plus 2x, and now I just need to find that b. Once again, we're just going to take the constant first difference as my y values, and these as my x values, and solve. So you can choose any one of these that you'd like. We're going to go ahead and let's go with, we'll just go with 4, 7. So I have a slope of 2, so when I plug all this in, 7 equals 2 times 4 plus 1, plus b. This will give me 7 equals 8 plus b, and when I solve for b, I'm going to get -1 equals b. So now that I have that, I can go ahead and write my recursive equation is f of x equals f of x minus 1 plus 2x minus 1. And that's it for recursive. So now what we're going to do is we're going to switch gears and we're going to look at explicit. So here's the list of rules. So what we're going to do is write the standard form of these equations. As you might remember, guys, it's basically we're trying to figure out the y equals mx plus b version of a quadratic equation. So instead of getting a final answer of like y equals 2x plus 7, we're going to get something a little different. This one's linear. We also looked at exponential form. If you guys remember that, that is like y equals 4 to the x power times 3. I'm just making these up off the top of my head. You have your initial, you have your growth factor, all that fun stuff, okay? So then now what we're going to do is we're going to look at a quadratic equation. The quadratic equation is y equals, or f of x equals, ax squared plus bx plus c. Something of this might look like, we have a few written down here, but like y equals 2x squared plus 7x minus 1, or y equals, it could be a fraction like 1/4 x squared plus 5x minus 1, okay? What I want you to realize is the leading coefficient always has the x squared attached to it, followed by the x, followed by the 1. And what we need to do is find those coefficients in that constant of c, and they're defined by the a value, the b value, and the c value. The a is always attached to the x squared, the b is always attached to the x, and the c is always going to be the constant. So what we're going to do is actually figure this out. So we have the list of these instructions here, and it says first what we need to do is always find your a value. So when I'm writing the explicit form, when I'm basically writing standard form for a quadratic equation, what we need to do is find the a value first. And to do that, all it is 1/2 of the second difference. From there, you just choose an x and a y, or an x and an f of x, and plug it into your equation, and then you are going to use substitution or elimination to solve for b and c. So let's go ahead and look at this. We're going to look at a familiar table really quickly. So if I have this table, same one we had previously, we had 1 block, 3 blocks, 6 block, 10 blocks. Let's go ahead and look at this. So we already had this, but we'll go ahead and make a quick one really quickly. So I have 1, 2, 3, 4, well, I even had the 5. And my y values were 1, 3, 6, 10, 15. My first difference was 2, 3, 4, 5. And my constant second difference was 1, 1, and 1. Okay? So now what it wants us to do is write the explicit equation. Remember, the explicit equation is, we're trying to figure out this equation in standard form. So y equals ax squared plus bx plus c. And my first step is always to find a. And if we remember, a is equal to 1/2 of the second difference. So the second difference in this one is 1. So a equals 1/2 of 1. So that means a equals 1/2. Perfect. So out of all this, we just figured out a equals 1/2. So this is what I currently have. This will be my solution area. Y equals 1/2 x squared plus bx plus c. So what I need to do now is that when I look at my table, you're going to choose 2 points and plug them in. So it could be any of these 2 points, and we're just looking at the regular x, regular y. I'm just going to choose the easiest points in my opinion, 1, 1, and 2, 3, and plug those in. So I'm going to have 2 equations. The first one, we're going to be using points 1, 1. This will give me 1 equals 1/2 of 1 squared plus b times 1 plus c. My second equation, we're going to use the 2, 3. So this will give me then 3 equals 1/2 of 2 to the second power plus b times 2 plus c. So let's go ahead. I'm going to start by solving this one in red. For this, simplify the red one as far as I can. So go y equals 1/2 times 1 plus b plus c. This would give me 1 equals 1/2 plus b plus c. And when I subtract 1/2 on both sides, it will give me 1/2 equals b plus c. Over here now, I'm going to get 3 equals 1/2 of 4 plus 2b plus c. 3 equals 2 plus 2b plus c. When I minus 1 on both sides, I'm going to get 2 equals, when I minus 2 on both sides, I'm going to get 1 equals 2b plus c. So now that I have these two, all I'm going to go ahead and all I'm going to do now is solve for b and c using substitution or elimination. Now in my opinion, when we look at this, the easiest thing is just to eliminate those c's. So if I move this over here, it's already set up quite nicely. And all I'm going to do now is subtract the top from the bottom equation. Sorry, I'm going to subtract I'm going to just go ahead and subtract these now. And when I do this, I'm going to move this up here so I get positive values. Okay, so then when I subtract these values, I'm going to get 1/2 is equal to b plus, and if you notice, These get eliminated, so I don't need to do anything there. So look at that, I got my b value. So all I need to do now is find my c. And how we're going to do that is I'm going to plug in all my values and 1 point to solve for c. So let's go ahead now and do that in pink. So I'm going to plug in now the point 1, 1 into the equation y equals ax squared plus bx plus c. And I already know my a value, I already know my b value, and I'm plugging in values for x and for y. So this will look like 1 equals 1/2 times 1 plus 1/2 times 1 plus c. So then when I solve this, I'm going to have 1 equals 1/2 plus 1/2 plus c. And this will give me 1 is equal to 1 plus c. And when I minus 1 on both sides, this will give me 0 equals c. So now that I have my a, my b, and my c value, in blue I get the explicit form of y, or f of x, is equal to 1/2 x squared plus 1/2 x. You could plug in the c value for plus 0, but not necessary. Okay, so let's go ahead now and do this here. We got a second one. We got a bunch of, we just got a sequence here. So I have my 1, 2, 3, 4 terms, and I have my values of 10, 23, 40, and 61. And the first thing what we're going to do is see if these values are linear by seeing if it has a constant first difference. And if I did this, I would get 13, 17, and 21. So obviously I do not. So now if we do it though for constant second difference, I see it's 4 and 4. So now what we're going to do on number 2, it says find the recursive form. So remember what we're trying to do is come up with the form of y equals ax squared plus by equals c. And what we're going to do there is, first things what we're going to do is find the a value, which is always 1/2 the second difference, and my second difference is 4. So that means my a value is 2. Now that I know my a value is 2, I'm just going to plug in 2 points to come up with 2 separate equations. And I am going to do 1 and 10 and 3 and 40. So we're going to do that here. So 1, 10 and 3, 40. And we also already figured out that my a value is equal to 2. Okay, so now let's go ahead and plug everything we know into the standard form. And remember it one more time, that's y equals ax squared plus bx equals c. And I said equals c, I meant plus c. So what we're going to do is plug everything in now. This is my x, this is my y. So I'm going to have 10 is equal to 2 times 1 to the second power plus b times 1 plus c. And then over here in blue, we will have 40 is equal to 2 times 3 to the second power plus b times 3 plus c. Okay, so let's go ahead and solve these two, or I should say let's get them most simplified. This will give me 10 is equal to 2 times 1 plus b plus c. This will then give me 10 equals 2 plus b plus c. And when I subtract 2 on both sides, this will give me 8 equals b plus c. So it's the most simplified form there. And back over here in blue, I'm going to have 40 is equal to 2 times 9 plus 3b plus c. Now I'm going to have 40 equals 18 plus 3b plus c. And when I minus 18 on both sides, I'm going to have 22 is equal to 3b plus c. So now what we're going to do is just going to go ahead and solve for b. And here I can just go ahead and eliminate my c's by subtracting. So if I subtract all this, my c's will get eliminated, and I'll be left with 14 is equal to 2b, which means 7 equals b. So I got my second value here. I got b equals 7. So now we're going to choose one of these points to plug in. And in orange, I'm just going to go ahead and do it right here. And I think 1, 10 looks easy enough to plug in. So this is going to I'm going to plug in this for y, this for x, this for a, this for b, and to solve for c. So we can do it right here to keep everything nice and organized. So this will give me then 10 is equal to 2 times 1 to the second power plus 7 times 1 plus c. Go ahead and move this over to clear up a little bit more space. Okay, so now let's go ahead and continue to solve this one. And we're going to solve for c here by having 10 equals 2 times 1 plus 7 plus c. And then we're going to have 10 equals 2 plus 7 plus c to have 10 equals 9 plus c. And when I subtract 9 on both sides, I am going to have c is equal to 1. Now that I did all of that, I can go ahead and write it in standard form. And we can do that in red, which is just y equals 2x squared plus 7x plus 1. Okay? This is the standard form. This is the y equals mx plus b version of quadratics. And remember, the whole point of this is to solve for a, solve for b, and solve for c. Last one. So same idea, guys. What we are going to do is make the table of the given sequence. And to do that, what we're going to do is we're just going to have the first, second, third, fourth term of 4, 16, 36, and 64. So the first thing that we need to do is find the first difference. And the first difference here then is just from 4 to 16 is 8. Then I go to 20. And then from 36 to 64, I believe that's 28. Made a mistake somewhere. Hold on one second. So let's go ahead and do this one more time. So to find the constant first difference, let's go ahead and do that from 4 to 16. I wrote 8 originally. That is wrong. That would be 12. This would be 20. And then from 36 to 64, that would be 28. There we go, much better. So then when I go ahead and do this, the difference from 12 to 20 is 8. And the difference from 28 to 20 is also 8. So let's go ahead now and figure out this formula. And we're going to first do this by starting off by finding the a value. Remember, the a value is just 1/2 the second difference, so 1/2 of 8 is 4. So now I have my a value as 4. We are just going to choose 2 of these points, and I'm going to just choose 1, 4. And then I'm also going to choose 2, 16. Okay, so let's go ahead then and plug these in. I am going to have 4 is equal to 4 times 1 to the second power plus b times 1 plus c. And then over here, it's going to be 16 is equal to 4 times 2 to the second power plus 2b plus c. Now in blue, let's go ahead and start by solving the blue or simplifying the blue one first. 4 is equal to 4 plus b plus c. And when I subtract here, I'm going to have 0 is equal to b plus c. And over here, when I go ahead and solve this then, I'm going to have 16 is equal to 4 times 4 plus 2b plus c. This will give me 16 is equal to 16 plus 2b plus c. And when I subtract 16 on both sides, I'm going to have 0 is equal to 2b plus c. And over here, I'm going to have 0 is equal to b plus c. All right, so then when I go ahead and solve, I'm going to have 0 is equal to b plus c. And then when I subtract these, I'm going to get these eliminated, and I'm going to have b equals 0. Okay, now just because you have a b value that equals 0, that's okay. That's no problem at all. So same idea now. I'm going to plug in these values. And I'm going to use the point 1, 4 for my point I'm going to plug in. Okay, so that's what it will look like. 4 is equal to 4 times 1. And remember, we have a 0 for b, so we don't even need that. A(n plus c. And when I solve this, I'm going to get 4 is equal to 4 plus c, and I'm going to get 0 equals c. So what does that mean then? If my c value is 0, my b value is 0, I'm going to have a final equation that looks like y equals 4x squared. And that's it. You don't need the plus 0 plus 0. For something that you guys remember, it's kind of similar to having something like y equals 2x plus 0. You don't need a y-intercept that is a positive or negative integer. It could also just be 0. Okay. Same thing, you don't need a b value, a bx, or a c value. It could just look like this as well. Okay. All right. So hopefully that, guys, helps. This is kind of like taking our discussion and we kind of mainstreamed it. So just remember, two things that we need to be looking at is recursive. It's always going to be f of x is equal to the previous term plus a linear equation. With this linear equation, guys, we have the second difference is a slope. The other part is to find the b value. What we're going to do is just take the x value, and we're going to take a value in the first difference and use the slope above to figure out what the b value is. Second thing we learned today is explicit. And if you guys remember explicit, it's what we just did here. First, we need to find the a value, which is just 1/2 of the second difference. Then what we do is we choose 2 points, plug them in, and then we eliminate c, and then finally we plug in all the rest of the values to come up with the final quadratic equation, y equals ax squared plus bx plus c. Okay? If you have questions on any of this, please let me know, and we will go over it next time I see you. See you guys later.